Okay, right, zero trust in the operating system domain. That's what I'm here to talk about today. And how policy-based containment's the word that we're going to use a little bit today, offers a viable zero-day approach. Okay, because zero trust is good, but with 0 day, that's where we really need to get to. Okay, so what we're going to look at for this session is we're going to start with an overview of the NIST zero trust model. And I've chosen it for particular reasons. Because I'm a pictorial learner, it's pictures, so we're going to see some pictures a bit later on. Want to understand why current detection-based approaches fail. I think we all know that hackers get away with stuff because we detect a little bit too late. And then how this policy-based containment raises the game. I'm not necessarily going to say it is the actual piece of magic that's going to stop hackers, but it's certainly going to raise the game. And then how actually, well, who are the vendors? Who are the emerging containment technology providers out there? Because there are a number out there already. And then what I want to move on to is, if we understand what I've said in all of that, is what's the challenge to the cyber community? And there are always challenges, but what are the particular challenges that I see that we need to overcome to a degree? And then what I want to look at is there's some emerging tools that make better use, that may not be the right, actually make more effective use of the MITRE ATT CK database. So moving on. Okay, I wanted to start with this quote, Donald Rumsfeld, Secretary of Defense, and when you can read his actual words online, people went, what the devil's he talking about? Okay, but what he really said was, in summary, is the really difficult things to deal with are the unknown unknowns. We don't know what hackers are thinking about. We don't even know what they're doing, even if they're doing it. Okay, you can't, but eventually, okay, you will detect them. So you can't detect these unknown unknowns until they somehow become visible to us. And that's when they become known unknowns, i.e. something's happened to my data. What is it? Don't know. Let's dig around. Let's find out what's going on here. Let's document it in MITRE ATT CK. So therefore, we've codified into the known knowns. And that's what anybody in the cyber world is trying to do, is trying to guess what are the unknown unknowns. Interesting. Okay. Finding out, well, we know that we don't know some stuff, then we'll document it so everybody else can make sure that particular trick doesn't come and bite our data on the backside. So the reason I've chosen this particular model, okay, which is American, because I'm a pictorial learner and I like pictures, okay? And I'm not going to focus on this particular slide in itself for too long, other than if anybody wants to go and read the full document, and it is a fascinating read that. And if you want to go and read the ISO frameworks or any of the other cybersecurity frameworks, feel free, okay? To my mind, this clarifies it in terms of what have we got? We've got systems, we've got resources, we've got policy points, and we've got some things that in the cyber world we already know about. So if we move on to the current feeds, those boxes on the left and right, continuous diagnostics and mitigation, i.e. we're looking at what's the state of assets in the network, you know, what operating systems we're running, what upgrades have taken place, is that asset approved on the network, is it not approved, do we need to patch it, what do we need to do, or what do we need to know? So we're constantly looking at that data with the tools that certainly larger companies have to keep on top of all that. Companies are then saying, well, are we compliant? What are we compliant to? Are we using the ISO framework, the NIST, the National Cybersecurity Centre? There are a number of them. And I'm not here to say that any one of them are right or wrong. It's just that organisations go, we want to go down that particular path. And this compliance is really important in the cyber world because for all the technicians that do their work, the business needs to know, have we done the right thing based on guidelines that have come down from the security gurus in the NSA, in GCHQ, etc., etc. Threat intelligence, so that's things like MITRE ATT, known vulnerabilities, known flaws, okay? Anything else that's out there that we can grab, shove into our system to work out what's going on or what's likely to go on. And then we get logs. We get logs from our network, we get logs from our computer, but we get logs from anything that can generate, okay, a log basically, internally and externally. So all the assets, so that might be all the home workers on their computers. We might even want to interrogate their router, not just their PC, if that's what we choose to do. And that's all feeding into the system. Then we have data access policies. Who can do what? That's fairly common stuff, okay? That is part of the feed, okay, that NIST's saying you have to have. Then we've got management and logging of certification requests. That's not just about security keys. That's not just about the public key infrastructure and stuff like that. That's about, okay, who's running what? Oh, somebody's just fired up an application over there in that particular building 100 miles away. Is that legitimate? Okay, is it viable? Is it software that we recognize as authorized? ID management, who's on the network, who's in the network, who's on the network via VPN, and so on. So there's a lot of stuff that the NIST model says you've got to have. And then you have these huge, what I call catch-all engines, SIEMs. We label them as EDRs, XDRs, and now we're seeing the term AI pinned on the back end of them, okay? And what these systems do is they aim to take all this stuff that's floating around that's saying, this is what's really going on, and attempt to analyze them and then flag things, whatever those things are, okay? Some of those things are going to be positive positives, some of them are going to be false positives, you're going to get false negatives, etc. All of that is where these systems try to kind of work out without necessarily a lot of human intervention. The problem being, from my experience, and I used to sell SIEMs back 20 years ago when they were fairly new, is that most people kind of go, there's just too much information already. Now, I don't want a system that gathers even more information. It better be smart at actually working out what is not noise, but what is stuff I don't need to worry about at the moment. Problem is, what you don't worry about at the moment might come and bite you on the backside a little bit later on. So, all these things are necessary, but they're not sufficient. Okay, we know that because all the companies that have got all this going on, they're still getting hacked. Okay, so zero trust, because that model that we saw at the beginning was about zero trust. The aim of zero trust is to reduce the attack surface through policies, okay, that fundamentally say, have you got access to the things that you need? And you're not going to get access to the things that you don't need. So I'm going to micro-segment. I'm going to maybe force you to do 2FA, 3FA, all that stuff that some of us feel gets in the way, but is necessary. Okay? That is zero trust in a nutshell. If you read through the NCSC wording, it's really policy heavy. Once again, it's probably worth reading it just to kind of get a feel for how you've got to wade through this particular bath of treacle. Okay, now the issue that I see is many vendors use the wording of NIST and the NCSC and others, and they flag that their products are zero trust capable with, the reason this is in a different color is potential for 0 day. I don't like the idea of potential 0 day. I much prefer absolutely it's 0 day capable. But the traditional model, okay, all those things that we looked at earlier, or we talked about earlier, they're potential, not capable. So, 0 day protection problem. It's a bit like whack-a-mole. I guess you've all played this, probably not recently. But the interesting thing with this game is, okay, you've got a whack-a-mole. It's a bit like, oh, the virus has popped up, whack it, kill it. That's how we detect things. The thing is, vulnerabilities are the key vector for 0 day attacks. So all the vulnerabilities that are in the software, that's what hackers are exploiting, fundamentally, at the end of the day. And the question is, when you played the game, did you ever manage to hit all the moles? Now, maybe if you played it for hours on end, you go, wow, I understand the pattern here. I know exactly which mole's going to pop up there. I am going to have the hammer, so it ain't going to show its head. That virus is not going to come up and attack me. But then it evolves into whack-a-mouse. So the hackers go, they sussed out whack-a-mole, we've got whack-a-mouse. So you're always one step behind in this detection game in the cyber war. Okay, so whack-a-mouse, okay, is the issue because vulnerabilities are baked into our environment. There is no piece of software that I know of that doesn't have a vulnerability. So we've baked in this problem. It ain't going to go away unless we suddenly decide to throw away all our current operating systems and start from scratch, and then be really ruthless at making sure people don't write code with vulnerabilities in. So if we want to look at a zero-day approach, let's go back to a fresh sheet and say, well, ideally, because we know vulnerabilities are out there, we want it to be agnostic of them. And if it's going to be agnostic of vulnerabilities at an operating system level, not just the operating system, but even the application systems level, it's got to be agnostic of the software changes, the updates that come out from various vendors. And wouldn't it be nice if it wasn't too worried about what operating system variant you've got? Windows, Ubuntu, Fedora, Slackware, SCADA. I don't know how, SCADA, which is the control mechanisms used in nuclear power plants, energy systems, a whole load of other stuff. Okay, so a true zero-day approach says that's what I want to deliver. And the purpose of this lecture is to work out, are we getting closer to that holy grail up there, which I will talk about as we move through. So let's go back to the document or the picture that we saw earlier on and just focus on this bit at the bottom. So the NIST model, okay, defines a clear structure to protect the enterprise resource, that box on the left of the screen there, okay? This model proposes to not trust any request until a specific policy is applied at the enforcement point. So it's basically saying every time somebody wants to get to that resource, you might call it data. Well, it is data. It's a binary 0 or a 1 stored somewhere. Okay. What's the policy for that? Inside the operating system, inside the application software. And this is where the vulnerabilities come in. They're aiming to defeat that policy enforcement point. And when you read through the NIST document, it really kind of alludes to that. That's the tricky bit. Okay. Thing is, once the vulnerability is being exploited, i.e. it can find a back door around the policy enforcement point, okay, then post-destructive activity is eventually detected. So that known unknown becomes an unknown known. Still don't understand what the hacker did, so now we've got to spend a huge amount of effort digging around, doing analysis, etc., working out what's done, and then documenting it in MITRE ATT CK or wherever we choose to document it. Okay, so this model says, yes, once you've detected, then you can stop it happening again, but we still need to detect it. So what we need to do is we need to put 0 day with zero trust. So going back to the whack-a-mole, okay, that's why our defenses are breached. We know why. And I use the term but. We know that we've got the likes of CrowdStrike. We've got Palo Alto. We've got Manage Engine. There's a number of them out there. These are vendors that are going, we can deliver that NIST model. The thing about the NIST model is it does not mention 0 day. You can't find that term in there at all. It's talking about zero trust. What it's not talking about is how the hell do I deal with unknown unknowns? So fundamentally, a lot of the vendors go, yeah, we implement the NIST model, okay? But really, and I'm not having a go at marketing people here, these companies got to sell their product. They're saying, we can deliver, okay, the NIST model. And fundamentally, the link on, when you get a copy of this presentation, that link below there is an article I wrote on LinkedIn, which kind of walks you through in a non-technical way what really we are talking about when we talk about this putting 0 day and zero trust together without all the marketing BS, as you might say, okay? Because as I said, there are companies that can deliver this and they ain't CrowdStrike, they ain't Palo Alto, they ain't Manage Engine. Okay, they do have a role to play in this industry and in this war against cyber criminals, but they are necessary but not sufficient. So what I now want to look at is containment and trust. Okay, because I'm talking about platforms that contain, we're talking about trust, that's the key word here. So let's imagine in this lecture, we said no phones, no USB sticks, no Google Glasses, no exceptions. Not even I can bring those into this room, okay? But the question is, what happens if I'm trying to show you how to run a penetration test from a smartphone? Is that a problem? No, well, we'll build an exception, a trusted exception that says, Pete, yeah, Pete can have a mobile phone. Pete can have access to the network. Pete can do various things. Pete can't go out on the internet, mind you, because we don't necessarily trust him, even though he's the lecturer. So what you do is you build a trusted exception. And what we're fundamentally doing there is saying, do I trust Pete? Well, I think I do. So we'll allow him to bring his phone in. Do I trust any of the audience? No. Not that they're bad people, but I don't want them to expose me to whatever issue might happen if they were carrying their phones. So what I've done is I've reduced the attack surface. Now, if anybody wants to attack this room, they've got to attack me, because you guys, you're not of any use to the hacker, because you've fundamentally been told you've got no mobile phones in this environment. So you won't be able to allow a hacker into this environment via that method. So containment and trust, and then allowing this concept of exceptions is really key to this, okay? And like any system, if you have too many exceptions, we might as well just throw the doors open and let you all have your phones and your USB sticks and try not to worry about stuff and hope that we don't get hacked. So we've got to go back to this model again and say, well, how does this model apply? Well, how can it be applied in this instance? Because we're focused on operating systems, okay? So the way to break it down is to say, I've got an actor. The actor wants to take an action and they're targeting something. And that's the real way to break it down. So what I call AAT. So let's look at what that really means. So the actor. In operating systems, you've got an actor called system, Windows, Linux. And you've got an actor called user. That's Pete, Fred, administrator, etc. The actions that the system or the user want to undertake is they issue a read request, or they issue a write request, or they try and launch something. That's all that we do when we're on our computers. And all the computer does on our behalf is read stuff, write stuff, launches stuff. It's no more difficult than that. And the target, is it related to a folder, a file, or memory? There's nothing else inside a computer. That's all it really is. So actor, action, target. What we now need to do is look at how we define that in terms of a security mechanism. So let's map the AAT methodology onto an operating system. So as I said, Windows fundamentally has two actors. It's got the system. That's the stuff that Microsoft, Sage, Oracle, SAP, Google, that's what gets loaded onto our computers. So when we ask a browser to do something, it does it for us. Okay, those things get updated. Those things have got vulnerabilities in them. There's the problem that we need to deal with. A user, that's you and me, we use products, we use Word, we use browsers, we download JPEGs, we read PDFs, we delete files, we do things. As long as we've got the right privileges. As a user, I can't go randomly installing new software, okay? But an administrator can. So a hacker will work out how to get into my computer as an administrator and go, I don't care that it's Pete. I'm not worried about Pete. I'm the administrator. I am now going to install some malicious code because I've worked out how to get around the policy, however I've done it, that allows me to be the super user for this system. So actor, action, target, okay, is the structure that if I define it as two things, users and system, okay, it becomes easier to understand as we move into how we go about what I call dampening vulnerabilities, because we can't get rid of them. They're there forever. Okay, so let's imagine, this is a crazy example, but let's imagine my video card has a software vulnerability, and I'm running an NVIDIA video card at home, but it's got a vulnerability that I certainly haven't spotted, nobody else has spotted, but a hacker somewhere in North Korea or China or wherever has. Okay, when that hacker throws something into my computer, okay, however they do it, via an email, via a drive-by, who knows, okay, the policy manager is going to be asking this particular question. Why is the system actor, a process called NVIDIA container, okay, issuing a read action to the memory of a running SQL service, which is the target? That's bonkers. What the hell's going on there? Yeah. So what it'll actually say is that's outside of the policy. Yeah. It doesn't mind NVIDIA asking to do something. It doesn't mind that the system actually requests that. Okay. But when you put those together, okay, it'll go, this is not right. This is actually outside of my policy boundary. So as it says there, one, if not all these policy checks will be picked up, because one might argue, well, NVIDIA containers never go and read anything. I'm not an NVIDIA expert, but if they don't ever need to read anything, immediately the action will get stopped. It'll go, you don't need to read nothing. Stop it. I will contain you here and now. Okay. So the thing is, it's this concept of contain it. It won't delete it. It won't kill it. It will just fundamentally put that chain process, okay, in prison. In fact, what actually happens with these mechanisms, they don't stop them. They just let them run. So that a hacker will just keep issuing or the actor, which is acting on behalf of the hacker, will just issue an action to read that memory, and it will never stop doing it. Okay? Because these new systems don't actually kill them off. They just stop them from enacting that particular path. Now let's imagine we work in R&D and we're experimenting with these direct video to SQL calls for whatever reason. Okay, what we do is we build a trusted exception inside the policy engine and say, okay, Pete and his R&D research development team, okay, they've got this exception, but actually it's only available to Pete. He's the head of the team. Okay, he's who I really trust at this particular point in time. So what I'm going to do is I'm going to allow, when Pete is doing something and nobody else, okay, the ability for my video card to actually request something via SQL. So what I've done is I've stretched very slightly, okay, my skin of vulnerability, but I haven't allowed it for anybody else, just me. So what I have to do is assess, do I trust Pete? It goes back to what we said, do you trust me stood here, that I'm not going to do something very untoward that's very harmful to this room? So what security analysts will be asking in the future is, what is the risk and how do we stretch that vulnerability if I need to? And I'll give you an example of where I came across this. I was working on solicitors. There's a very common piece of solicitor software. I won't name it, one, because I can't remember it at this particular point in time. But they had used one of the mechanisms that I'm going to talk about. And as soon as they installed it, because they said, yeah, we can install this, we know what we're doing, this piece of software failed completely. Now, it was cloud-based, so all the data was held in the cloud, but on each PC there was an application. And what this application was doing was it would fire up from system, and then it would go to user space, and then it would execute code, which is a really dirty way of doing things. If you're going to run system stuff, run it from system. Don't go to the user area in Windows and go, I'm launching from here. Because what you're really saying is, I'm acting as a user now. No, you're a system piece of code. So what I had to do was build an exception to say, this code is really dirty. Let it do that. And so long as no hacker ever finds out, and they will do one day, find out this piece of solicitor software, which is installed in about 170,000 companies worldwide, okay, that I've contained it. Okay, actually, I built some other containment policies in there to make sure that actually, even though it could run from there, some of the other stuff it was attempting to do, it could not. Okay, and if people want to ask specific questions at the end of the lecture or come up and talk to me afterwards, I'm more than happy to talk a bit more about that in detail. So if we look at the actual vectors for attacks, okay, hijacked apps and so on. Okay, these are common terms that, you know, pretty much most people, not necessarily in the cyber world, but certainly in the security world, will be heard about SQL injections, drive-bys, living off the land, and so on. Okay, but what I want to do is categorize them into, there are hijacked apps, there are application launches. Remember what I said earlier on, that what's happening is there's a request to launch something, so you read, write, or launch. And there's this thing called magical mystery process, which I like to call what the hell happened kind of issue inside our computer environments. So let's look at that. So hijacked apps. So living off the land, I don't know how many people are familiar with living off the land, but fundamentally it's where a viral load has moved into your environment, but it doesn't go rampant. It sits there quietly. Go look at Stuxnet, that was a classic one. That it sits there kind of going, oh, I'm going to poke something over here. Then I'm going to ask for some information from here. But I'm going to wait days to do this. I tell you what, the SIEMs and the EDRs and the XDRs, they're not going to notice what's going on. It's a bit like if I had a gunman up at that window at the back and he popped his head up on every 15th lecture, nobody in this room's going to kind of put two and two together and go, blimey, every 15th lecture, some bloke turns up there. I wonder if he's somebody who's going to actually break into this room. And an SIEM has got to store all that. So it's got to store ever more data about what happened days, months, years ago. So living off the land attacks sit there, okay? And they'll run things like PowerShells, I say quietly. They'll run them to the point where people don't notice what's going on. But eventually they'll have acquired enough reconnaissance that they'll do what they're going to do. Drive-bys. Well, we all download stuff. We can't help it. We have to. The way the world works is you've got to download stuff. Especially as organizations move stuff out into Google Drive. I used to have a lot of clients go, yeah, I'm using Google Drive. I'm perfectly safe. No, you're not, because we can drop junk into Google Drive and then push it into your system. Okay? Doesn't mean that you're safe just because you're using these large corporation systems, okay? And that as soon as these drive-bys try and run up, they'll come up against your policy is, what's the actor? Well, the actor appears to be user. But this user is attempting to launch something like an MSI. What? Okay. Do I stop it? Not sure at this point. Possibly, but actually their target is, blimey, it's a bit of memory. What's going on here? And that leads into this magical mystery process, because fundamentally that says this stuff makes no sense. This does not form the normal procedures that operations inside a computer, be they user or system, okay, are doing. And it's a bit like, imagine that Microsoft had written, here is the golden rule of programming. And here, if you follow this book, you would never end up with vulnerabilities. Okay, this is the best practice. If you don't do this, then you are opening the door to all sorts of problems. And it's a bit like what the magical mystery process part of this mechanism is saying is, well, you're going against the rules. And in essence, although Microsoft haven't written this magical book, it breaks down to, we've got two things. We've got system does system things. But system doesn't do stuff to itself that doesn't make sense either. And the users, they do stuff for users and they request stuff from the system. So those two, if you like, locks on the gate are where we say, okay, are we going against the policy? Now, I appreciate possibly for a number of people here, sorry, I didn't mean to hit the microphone, that it's a bit difficult to get your head around. And I'll be honest, the first time I came across the products that we're going to look at, I went, I understand the philosophy. I don't understand the mechanism. I do understand the mechanism now. So, how are we doing for time? Not too bad. I want to look at, because there are products that are out there. Okay, so AppGuard. AppGuard's been around for 17 years. When I worked a lot with the MOD, I heard about this concept of being able to ring fence, as they called it, operating systems. The guy from GCHQ said, can't tell you any more than that, but there's some interesting work going on out in America. I've actually met the guy who built this product. And it was like when I became exposed to AppGuard about three and a half years ago, it's like, oh, I understand the concept, I don't understand the mechanism. I then did some digging around to go, surely there must be other organizations out there that are doing something similar. And I came across OS Armor. I came across Threat Locker, and more recently I came across Droplet. So these are guarding and containment products. They actually fulfill this rule of agnostic, as we said on slide 7. Now, I just want to make a comment on here before I say something else. If you Google application guarding, what you'll get is you'll get MDAG come up. That is a detection system. It's like CrowdStrike or Barracuda, etc. Okay, and this is the difficulty. If you're trying to find out what is this brave new world of zero trust, Droplet call theirs never trust systems, then you're going to go off on a wild goose chase. Okay. More than likely, if you start typing in AppGuard, Droplet, OS Armor, Threat Locker, okay, you will get closer to where I believe the next generation of systems will take over. Now, what's important about these is they don't use artificial intelligence, not one of them, and they don't need to, because they know the golden rule of actor, action, target, and is it a system or is it a user? Those are the only things that they deal with. So as a précis, if ever you want to look at them, AppGuard is the one that's been around the longest. It's never been compromised. It was actually written by the CIA. I always take a view, yeah, they wrote the Onion router as well, and look where that got them. Droplet is a UK product. So AppGuard is an American product. It is very good at out-of-the-box window and, to a degree, Linux protection. You can almost take it out of the box. You can actually buy a personal version of this, put it on your computer at home, and go, wow. And you can remove your antivirus. You don't need an antivirus anymore. And it will stop all attacks. It will, because it's agnostic of vulnerabilities. It doesn't know what a virus is. Hasn't got a clue what a virus is. Hasn't got a clue what MITRE ATT CK is. Has no understanding of any of that. As does Droplet, have no understanding. As does OS Armor. I'll come back to Droplet in a minute. OS Armor is, if you're a real techie head and you've got time to read this document and understand the 250 different variables of vulnerability you can get inside Windows, then have a go at it. I just found it horribly complex. Didn't have enough time to deal with it. And then Threat Locker. Threat Locker's a fairly new one. I wish I could buy shares in them, to be honest. But you can't. Big investment banks are starting to pour money into them. Threat Locker, okay, is very much like AppGuard in terms of they're saying we can protect Windows environments, doesn't matter whether it's servers or users or whatever, okay, and we are agnostic of apps. Now, Threat Locker is not out-of-the-box agnostic. And the other thing about Threat Locker is it causes huge disruption while you're trying to implement it, because it can stop all sorts of stuff in its tracks very easily. Could be quite simple stuff. And especially if you're running very, very bespoke apps. I mean, it would have blown this solicitor software sideways if it had seen it. AppGuard has got, I'll be honest, if there's anybody from AppGuard listening, but it's got a bit of a, it's not a brilliant interface. It's not horribly technical, but it's just not brilliant from a user perspective. Whereas Threat Locker is what I call sexy. It's easy for people to do drag and drop and build. Okay? OS Armor, you've got to be a real tech head and you've got to keep on top of your game. Those all deal with operating systems that we all know about. But Droplet is a slightly different beast. As I said, they talk about never trust. To my mind, zero and never are the same thing in this particular context. What Droplet do, and that's, as I say, it's an English company, is that they, if you understand Docker or Kubernetes, they containerize the environment. And what they appear to do is look at what flows up and down the IP stack and say, stuff's leaking out of the IP stack, then what the hell's that all about? And it looks at what's going up and down the IP stack. They can containerize anything. They can take an operating system that somebody in the corner of this room writes tomorrow afternoon and never trust it. They can protect SCADA systems. In fact, they do protect SCADA systems. They don't care, but it's not totally out of the box. Okay, so if you are a security specialist in a commercial organisation, looking at any of those, you've got choices to make. Okay, but the important thing is they're agnostic. They deliver that slide 7 for us. So this goes on to what's the cyber community challenge? That we've all been using tools for a long, long time, and we've got faith in EDR, we've got faith in XDR if we use them, and we're getting faith in AI. My personal view of AI is somebody's artificial intelligence is somebody else's artificial stupidity, and criminals will exploit that. They just will. So, but they're still detection only. AI will still be detection. It will just be working out how to hit the mole quicker, and then the mouse. That's all it can do. It cannot know the unknown unknowns. Well, maybe it will eventually, I don't know. So in terms of cyber teams, okay, this leap of thinking to go from detection and trust containment, which is pre and post execution, means, have I got to spend a lot more money? To which the answer is yes and no. Remember that EDRs, XDRs, they're good at when they detect stuff at removing them because all the systems will come into play, put stuff in quarantine or just delete it, but maybe put it in quarantine because we want to look at what is this stuff before we delete it. Okay, that's the necessary but not sufficient bit. And the other issue is the lack of human resource. So the problem that most people who run EDRs and XDRs is, do I run it in-house? Build a big team of people that cost me a fortune, okay, and hope to God they're really good at whack-a-mole because they'll be looking at all this data coming out of the EDRs and XDRs and going, is this an unknown unknown that's turning into a known unknown? Don't know. Let's pile the resources in, okay? And that's a challenge. The real challenge also is there aren't enough people not wanting to, but there are enough people getting into this industry to keep on top of the growth that the hackers are creating. And as I say, hackers only have to be lucky once. We have to be lucky every day, and that's the challenge. And then we need to deal with this, especially if you are working for an organization where you are purchasing this wonderful stuff that I'm talking about, and go, is it all marketing rubbish? Is Pete just using wordplay here? Because once, as a security specialist, you understand how containment and isolation works, okay, you go, that makes much more sense. Does it mean I get rid of my EDR and XDR? The answer is no. They're necessary. They're just not sufficient. Okay, so don't get rid of them. Because zero-day containment, okay, only contains. So it allows this virus to rattle around, but it won't allow it to achieve its actual target. It won't allow it to achieve its action on the target. Sometimes it won't even allow the action. It won't say, you can't launch that. It will kill it immediately. Well, you can launch that. Oh, no, you can't do that because you are this user, or you are correct, but that target's not available to you. So you need the AVs, the EDRs, and the XDRs to remove the viral code. Now, obviously, if it's an unknown that's turned into this now known, okay, all of us diligent people will then start to update the MITRE ATT database. So these two things, the containment isolation systems and the detection removal systems, okay, create, okay, while working together or in concert, the zero trust, 0-day barrier. So what I want to do is to move on to what's MITRE ATT's role in this? Because it's a superb repository for the cyber community and hackers to look at. So it's a bit like this Bible of all known actors, actions, and targets. That's all it is. It's a big, wonderful database of this group did this to that. Okay, and they did it in this sequence, and they did it with these particular chains, and so on. But MITRE ATT has got no unknown unknowns. Don't know. Does it know about all the vulnerabilities in the software? No, never will. Okay. So it cannot spot stuff, okay, until it appears in the wild, by which time some damage somewhere has already been done. And I can't remember the exact figures, but I think I read somewhere that most organizations don't know they've been attacked, even when it's quite a rampant virus, for at least 43 days, okay? And if it's been a supply chain attack, then there'll be somebody else down the supply chain that's already been bitten, even though you've only just discovered what's actually been compromising you. So I think we need this smarter approach to cyber landscaping. So how do we go about doing that? So where we come across this Validato, Cheltenham-based organisation. Lovely piece of software. I'm sure there are others. I've not come across them yet. Okay. So better tools for penetration testing. I mean, I was selling penetration testing tools 20 years ago. Qualys, Nixon and stuff like that. Okay. We're now moving into the world of, oh, you need continuous penetration testing. Kind of agree with that. Okay. Does this answer the problem if you've got red, blue, purple teams and so on? It's a lot of resource you've got to corral. Okay. That's expensive resource. And as I said earlier, there aren't enough people coming into the industry to feed that machine. So what Validato have said is, do you know what? We're going to take the MITRE ATT CK database, okay, and we'll keep on top of it, because every time it gets updated, they take in that data. And then fundamentally, what I need Validato to do is say, from a compliance viewpoint, not a technical viewpoint, okay, look at the 50 top MITRE documented attacks today, and then match those attacks against my environment, okay, and produce me a standard report, whether it's CSF format, ISO format, NIST format, so that somebody can almost on their computer go, I just want this system to tell me, given that I'm running, I don't know, Norton Systems or Cisco Security or Microsoft, I'm running Defender or whatever. Can you tell me, with those attacks, what my vulnerability level is? And it'll come up with a number. You can then say to it, what happens if I plug AppGuard in? And you'll see those numbers drop without a doubt. Because remember, AppGuard doesn't understand a virus. It just understands actor, action, threat, target. Okay, so I think tools like this will, if you like, take the heavy lifting load of cyber teams who are ever trying to work out what the hell might happen. This is saying, okay, this is what will happen if you stay with Microsoft Defender. This is what will happen if you upgrade it to McAfee systems, or this is what happens if you downgrade it to something else, so that you can work out from a compliance viewpoint, am I increasing or decreasing my vulnerability landscape, and how much is it going to cost me to change that? Systems like this, okay, will allow you to assess, i.e., these products that I've already got, how good are they? And it's almost automating, to a degree, that level of understanding. Okay, then it helps organizations go, so if I'm running, let's say, Microsoft Defender, and I'm getting an answer of 75%, am I bothered about the 25% risk based on the top 50 MITRE attacks? Well, that's only the question the guy with the checkbook can answer, because he'll go, hang it, we'll take a risk on that one. Okay. Not necessarily one I would take, depends on what the situation is. So this is a tool, Validato, that helps organizations assess, do I need to move towards containment? Because let me tell you, although I think containment and isolation is brilliant, when I thought SIEMs were brilliant, could I get the banks I work with to buy them? No, we've already got antiviruses. Yeah, but they're not good enough. Most, if not all, banks have SIEMs now. They didn't 20 years ago when I was trying to sell them to them. So, the key messages: actor, action, target, containment works. It is agnostic. Detection systems are required for cleaning out the viral junk. Actually, those systems are also good. I always take a view, even in the days of the early firewalls, don't sit behind your firewall going, I am protected. You want to stand on top of the firewall and go, wow, the enemy's getting bigger, larger, and better prepared. Yeah, so those detection systems, you need to detect how big the tsunami, the threat coming towards you is, because that's actually good to know. Why am I being targeted? You know, with the current Elon Musk situation, it'll be, well, because you said that to the president. That's why we're being targeted. It's as simple as that. Okay, so these detection systems are still necessary. They're still good. Don't get rid of them. and that things like Validato with their vulnerability assessment tools, okay, to my mind, gets more value out of MITRE ATT CK. If you're an expert, you can read MITRE ATT CK like it is, you know, a Sunday newspaper. I look at it and go, wow, there's just too much stuff to get my head around here. Can somebody synthesize this, please, in a normal format? And I've got a background in cyber. So these tools, I feel, okay, are the next generation that will up the ante against the hackers. Okay. One interesting point, what happens if the hackers get hold of any of these tools? Okay. AppGuard cannot attack itself. Neither can ThreatLocker, because it goes, it's actor, action, target. Why am I doing this to myself? It'll stop itself. You'd have to rewrite the code to get it to not do that. So they're almost self-protecting as well. So, on that note, any questions from anybody in the audience? Okay. You are right, and I think the answer to that is to go back to to when, I can't remember his name now, the founder of AppGuard, who was actually, it was a university project he was working on, the CIA approached him, because I understood what he was saying is, system does this, users do that, and it's not that the boundaries can't cross, but there are definite rules that if only Bill Gates had written them down, we should have all followed. Yep, so, and that fundamentally from Windows XP onwards, Windows has not changed in the way it works. Okay, and so long as Bill Gates doesn't rewrite Windows, we're okay. I say we're okay. Yeah. What about the variants of Linux? Well, Linux, although there's lots of variants of it, okay, fundamentally follows a set of rules that if only you would obey them, we wouldn't have vulnerabilities. Now, the challenge is that all programmers, and I used to be a programmer, is you kind of say, I want to do something. I want to access this particular file block. What I'll do is I'll open it up for read and write, because I know I want to read it now, but I might want to write to it later. So I'll open it up for read and write, and then I read it, and my code works. And I forget later on to remove the write access to, or the write request, because I've opened up that block. A hacker will go, wow, they're reading it, but I know I can write to it. So what I'm going to do is I'm going to use that vulnerability to get in. And the thing is, that what happens is with containment mechanisms, the actor action target is a series. It's not just one action, okay, on one target. There's steps that take place. So at some point, a containment system will go, whoa. Okay, so the virus, for want of a better term, might get so far in, but it cannot complete its action. Okay, whatever that action is, and the earlier we can stop it, the better it is. So I don't know if that answers the question in terms of what happens if because things won't change in Windows, things won't change in SCADA, things won't change, to be honest, in the IP model and the way it stacks from layer 1 up to 7. And therefore, these models should apply and be agnostic until we invent some new technology that looks nothing like what we've got. Whether quantum computing will change that, I don't know. But yeah, I mean, that's what it says. The analogy I always use is when you get, you know, I talked about the USB stick and the Google glasses and the mobile phone. None of us are allowed to carry sharp objects onto an aeroplane, are we? Why? Because we might use that to do something. Is the pilot allowed to carry a sharp knife onto the aeroplane? No. Why not? He's the pilot, for God's sake. Yeah. Can I trust him? Well, I can trust him to fly a plane. Can I trust him to go AWOL in the cabin? No. Okay. But the thing is, do I need sharp knives on the aeroplane? Well, at certain times when it's landed and I'm trying to cut something, i.e. fit a new seat cover, absolutely. So basically it is, what is the requirement for this environment at this particular point in time? And the policy has to takes all that into account. Yep. And that's fundamentally what it is. Yep. Okay, any other questions? Yep. Yeah. Yeah.
These things that need sort of continuous training, rule basing, etc. How do they work in practice?
So that's a good question, because it talks about what are the updates. So, and I'm more familiar with AppGuard. AppGuard, I think in the last 2 years have made 2 changes. One of them was because Google Chrome suddenly decided to do something really weird with a memory block when they were printing. And they wrote some weird vulnerability inside their system. And AppGuard just went, that is so illegal. That is bonkers. Yeah. And it just stopped Chrome working, full stop. So what they had to do was say, okay, that is really weird. What we'll do is we'll build an exception to it. Yeah. All the systems that I've ever played with on AppGuard, if you install pretty much any standard software, okay, that's from a trusted publisher, be it Audacity or be it Sage or be it OpenOffice, it just goes, that's fine. What AppGuard will report and ThreatLocker will report is, wow, this code's really crap because it's trying to do stuff that it doesn't need to do and I'm stopping it. I.e., it wants to read and write to a block when it should only be reading. I'll tell you what, I'm going to stop the write. And if that app actually doesn't need to write, it doesn't matter. The app just generates a log, or these tools that generate a log that go, this software is really crap. You just need to know it's really crap. Okay. Whether you want to report that to your programmers to get them to write it properly is up to you. Yeah. So that the thing with these containment models is, and I don't know if I could ever put a percentage on it, but the 99.9% of the time you can make changes to your software, be that Windows upgrades or that your SQL upgrades or whatever you're using, is not going to cause a problem, other than every now and again a major company is going to do some real weird stuff that will just cause them to contain it. Then you need to work out, what's that log telling me? Let's open up the vulnerability just a tiny bit, but just that tiny bit. Yeah. 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 What you say? So with that solicitor software, when I came across it, I wasn't myself sure what was going on. So I basically talked to the help desk in the US, and we had it sorted within 4 hours. the Google Chrome one, I think that was sorted within 10, if not maybe a bit quicker. Yeah. It doesn't matter, because all it's just saying is actor, action, target. Yeah. Yeah. And I think that's true. The issue with other policy systems are you need to keep fiddling with them, for want of a better term, because the environment's changing. Remember my slide that says it's got to be agnostic? These tools are agnostic. It is really it's an interesting concept to get your head around until you see them in action. And believe me, I can talk about it for the next 20 hours. And you have to see it, and you have to sit down with the technical people I went through an 8-hour course with AppGuard, and eventually at the end of it I thought, wow, I totally understand what this is doing. I am not very good at explaining that in a 1-hour lecture, I'm afraid. Yeah. Okay. Any other? Sorry. Yeah. Yeah. Yeah, that's the thing with DOSs. I mean, that's why was it X had those problems, because it was just a DDoS that was going on. They reckon they're not absolutely sure, but yeah, DDoSs or DOSs. Okay. Interface. It's less technical. It's much more business friendly. So, and it only protects Windows. It does Linux. I think it does iOS as well. Droplet. I've not seen it in action, but it can protect any damn thing. It's not out of the. It is. It's not. Is it out of the box? Not completely, but it's very rapid to deploy. The issue being is it's a small UK company, and do you trust them? To which my view is, well, you don't know the guys at AppGuard or the guys at ThreatLocker. Do you trust them? Go talk to them and make that decision. Yeah, so no one of them's right, if you like. No one of them's a perfect fit for every particular requirement. All I can say is, if you want to control your SCADA systems, you should be using Droplet, because the others don't even know what the heck that is. Yeah. So it's one what? Mm, Possibly. I would still say, though, that what you want to do is feed all the logs from your containment systems into your EDR and XDR. Because remember, that's those feeds that we were coming in the NIST model. The more feeds you can get in here, the better view you can take of the actual shifting of the threat landscape that you're experiencing. Yeah. So does that answer your question? Yeah, yeah. Is this a magic bullet? It's a better bullet. Okay, is it the be all and end all? I don't know, but I just feel that it's the next generation that's coming on, and whether AppGuard or ThreatLocker will be the players, or whether they'll get eaten up by Cisco or some other player and merged into their product, I don't know. This will be a rapidly changing landscape, depending on, if you like, how the money moves around in this industry. Any other questions? No. Well, that's an interesting question, and technically, I'd take a view because it's just looking at the policy enforcement point. What's the action target? That's a very simple question because it's going to go: is it system? Is it user? Is it read write? Is it execute? Is it file? Is it memory? Yeah, that's a very simple question to ask. It doesn't need any decisions made. It just says the policy says no. Yeah, so it's not a decision engine. Yeah, it's pure raw policing. I.e., so every time you go to the airport, if you're caught carrying a knife, they just whip it off you before they maybe take you to prison. I don't know, but yeah, that is a very simple policy to implement. No knives. Yeah. Is there any questions off the internet? Yeah.
How will they sort of integrate together? Zero Trust that works in these applications who work on the OS. Do they need to integrate with one another?
That's an interesting question. I take a view, and it might be a bit loose and cavalier, I don't know, is I don't care that these threats come into my network because other than DOSs, the only reason I'm attacking your network is because I want to get to the data. I don't really want to get to your Cisco router or your Juniper switch. I actually want to get to that data and steal it and sell it. That pretty much, not every, but pretty much the hack is the gold dust is the data. Now, how you get to it might mean compromising your firewall, etc., etc. So one could argue maybe what we'll see in future is that these systems will evolve to, containment inside Cisco's or your Junipers, etc., etc. And that may well happen as we can get faster chips and we can slim down some of the code that does this. I don't know. Yeah, but that's my kind of guess at what might happen there.
Online, we'll type in the chat.
If you've got adequate protection, you're doing a solution.
You could run Validato against it. I mean, which sounds a bit glib, okay? But at the moment, that's the only thing we can do. The other thing is, there's no reason why we can't run vulnerability testing, and we can run our red team, etc., etc. They don't need to go away. What it is about is saying, how do we make better use of them, rather than running around chasing their tails, especially when we do get... The thing is, when we get compromised, we all panic and go, what the hell happened there? And you buy all resources in if you've got it. And a friend of mine was a chief security officer for a large American corporation. And I said to Jeff one day, we go out walking a lot, and he said, do you know what? I just get really fed up with 3 o'clock phone calls from Australia when something's going on which turns out not to be any problem at all. And he said, if you talk to any chief security officer, their real problem is the stuff that keeps them awake when actually it wasn't a problem, because you need to make sure it's not a problem. Yeah. So I don't know if that kind of answers it's more of a philosophical and action thing. Yeah. Okay. That's a jolly good question. I'll tell you what the biggest issue was. We were, and I've since retired from the company I was working for, but at an accounting firm, and I couldn't even remember the name if you asked me. So they said, run AppGuard in discovery mode. They liked it. And then they went, hang on a moment, AppGuard actually generates unpublished code as part of its interrogation of the way it works, the way it probes the systems. And it's like, does it? So what we're saying is unpublished code, i.e. non-trusted publishers, is an issue, and yet your code's doing that. Now, it turns out the reason for that is because AppGuard goes, well, I cannot be compromised, therefore I don't need to worry about the fact that I publish not things that haven't got a trusted certificate against them. Okay, And it was like that kind of brought things like that to a halt. So I think what happens is you get, and I'm not having a go at security people, is that you kind of think you are going against the grain that I believe in for the last 10 or 15 years. And you've told me A, B, and C, and now you're telling me, no, it's A, B, and Z. What's going on here? And I think it's that level of not sure yet, okay? But it goes back to what I said, SIEMs, when I was selling them years ago, I knew they were the answer then. God, I was talking about them back in 2000 when they weren't even, well, and it's like, I know that this is the future. No matter how hard I shout at you, I cannot convince you. But when you get attacked and you go, I remember Pete saying that, you will come to me. But that's a detection model. Oh, I'll go to him now that I've been breached. But that's the way all human beings work. I think I'm okay. Kind of understand what you're saying. Go away now.